video, I would be looking at the normalization concept in databases. First of all, why normalization is needed? In real-world databases, data is divided into multiple related tables. It is not stored in one big table for various reasons like to avoid duplication, maintain consistency, and improve performance and structure. Let us take the example of this table which has unnormalized data. Here each transaction details are stored in this table. So here we see Alice and Delhi are repeated every time the order is placed. So the data is getting repeated, and if Alice moves to another city and we want to update her city, then we need to update her details in every row her data is repeated. And we can have a inconsistent data risk. Like for suppose if Alice is mistyped as table E, then also we will consider it as a new customer. So that inconsistency is there. In order to address these issues, we will be normalizing the data. Normalization is the process of organizing data into multiple related tables to reduce redundancy and improve data integrity. It is breaking a large messy table into smaller logical ones and linking them using keys like customer ID or employee ID. Let us look at how normalization can be achieved. Normalization is done gradually in stages called normal forms. Each stage or normal form fixes a certain kind of problem. The three main normal forms are first normal form, second and third normal form. But in complex system, you also hear BCNF, boys code normal form, 4NF and 5NF, but it is rare. So first we'll look at this example and see how we can normalize this data. So we have a student's enrollment table. So here you can see in each cell we have multiple values. So the problem is in multiple values exist in each cell, and because of such multiple values in each cell, it is difficult to query or update. And then even the data is repeated, or instructor's name is repeated, courses are repeated. So let's see how we can handle. So first we will go with the first normal form, where the rule is every cell must contain only atomic values. I mean single value should be there in each cell. In order to address those issues, whatever multiple values are there, we have taken them into separate row, and this form we have created. So this is after applying the first normal form. But if we look at after applying the first normal form also, the problem we see is data is still repetitive. So now we'll go to the second normal form. The second normal form rule is to remove partial dependencies. I mean, what is partial dependency? Partial dependency is like whatever columns or fields are there which are not the primary key, they should completely depend on the primary key. So let's take the same example. In this table, my student ID and the course form a composite primary key. So here if you see, student name depends only on student ID. Yes, so here student name depends only on student ID. So that is good. And instructor name depends only on course. So instructor name depends only on course. But actually ours is a primary composite key. So each non-column value, that is instructor name, should depend on student ID as well as course. And student name should also depend on the student ID and course. But that is not happening. In order to address those issues, what we do is, First, we'll see what are the problems caused by partial dependencies. Instructor name repeats for every student in the same course exactly. Data redundancy applies, and there would be an update anomaly. If we want to change instructor's details, you must update in multiple rows. Insert anomaly, that is if you want to add a new course, a student should register. We can't just add the course details. And in the same way, delete anomaly. Like if all students drop from one course, that time even the instructor's details are gone. So that is the reason to address this issue. What we are doing is we are splitting the tables into two tables so that all the student details depend on the student ID, the whole primary key, and in the same way here also in the courses these details depend on course or primary ID. Now we'll come to the third normal form. The rule of the third normal form is to remove transitive dependencies. Transitive dependency in the sense indirect dependencies. So what is like partial dependency? We have seen every key column should depend on the whole primary key. Whereas in transitive dependencies, we should even remove the indirect dependencies, like no non-key column should depend on another non-key column. But when we see at our data, we see the instruction details are dependent not only on the course, they also depend on instructor name. More than course, they are more dependent on instructor name. So these are transitive dependency. Again, what are the problems caused with transitive dependency is instructor details repeat on each course, and update anomaly. If we want to update instructor details, we have to update in multiple rows. Again, if we want to add a new instructor, we have to make sure there should be a course because it is dependent on that. And even if you want to delete a course, then because of the course detail deletions, even the instructor's contact info might lose. So to address that issue and to remove the transitive dependencies, we have created a separate instructor table. So the instructor table is separate. So how many instructor details you want to update, you can update in that own table. So finally, after applying third normal form, we have these four tables. First is the students table with main data. Then we have courses table where we have instructor ID, and with instructor ID we can fetch instructor details also. We have another enrollment table to connect the course ID and student ID. Here we could have, what we could have done is course ID can be given in the students table itself. But to ensure that if each student might enroll in more than one course, to ensure that we have taken another table called enrollments. So after our normalization, we have final normalized structure as these tables: students, instructors, course, and enrollments. So once the data is normalized, we use joins to bring it together for queries and analysis. Thank you.